The teeth enter the frame before the animal does, a row of thick, conical teeth lowers through the morning haze, wet with mud and shadow. The skull behind them is enormous, deep and heavy, built like the front end of a living machine. The jaws open over a carcass half, buried in a late Cretaceous floodplain, and for a moment the whole world seems to narrow into bone, bite, and pressure. Then the camera pulls back. Under that massive chest, almost hidden in shadow, hang two small arms. They look wrong. Not just short, not just awkward. They look like a joke attached to one of the most powerful land predators ever found in the fossil record. The head fills the scene. The neck is thick. The legs are pillars. The tail balances the body behind. And beneath the chest, the arms seem almost forgotten. But the joke is too simple. Tyrannosaurus rex did not become a giant predator by evolving every body part in the same direction. It became specialized. Its body did not say, make everything bigger. Its body said, move the killing system to the front. That front was the skull. A T-Rex head was not just a head. It was the main weapon, the main feeding tool, the main contact point between predator and prey. The skull was deep and reinforced. The jaws were massive. The teeth were built for gripping, puncturing, and crushing. The neck had to support that enormous front load. The chest and hips had to balance the entire animal as it moved. In that body plan, arms were no longer the star of the hunt. That does not mean they were useless. The fossil bones show that T-Rex arms were small compared with the body, but they were not paper, thin decorations. The forelimbs had muscle attachment areas. The hands had two functional fingers. The arms likely had strength in a limited range close to the body. They were small, but not necessarily weak in proportion to their own size. The real question is not, why did T-Rex have silly arms? The better question is, why did evolution allow the arms to become so reduced while the rest of the predator became so extreme? Look at the animal in silhouette. The skull dominates the front of the body. The neck slopes into a deep chest. The arms are tucked close, barely reaching beyond the torso. Behind that, huge hind limbs carry the animal's weight, and a long tail counterbalances the forward mass. This is not a balanced cartoon monster. It is a body shaped by trade-offs. Every structure has a cost. Large arms require bone, muscle, blood supply, nerves, and developmental investment. They also change balance. They can get in the way. They can be injured. They can be grabbed, twisted, or crushed. During close feeding, if the head has already taken over the primary work of killing and tearing, keeping large grasping arms may become less necessary. In many earlier theropods, the arms mattered more. Some meat-eating dinosaurs had longer forelimbs that could help grasp prey, but tyrannosaurs followed a different road. Over evolutionary time, their skulls became larger and more powerful, while their forelimbs became relatively shorter. The animal's predatory emphasis shifted forward into the head and jaws. Picture the carcass again. The T-Rex does not need long arms to reach it. The skull is already there. The jaws clamp down. The neck pulls. The body leans with its weight behind the bite. The tiny arms remain close to the chest, moving within a narrow space where they are less likely to be trapped under struggling prey or torn during feeding. One hypothesis is reduced need. If the jaws and skull became powerful enough to seize, kill, and process food, large arms may have lost much of their earlier importance. Natural selection does not preserve large structures just because they look impressive to us. If a body part is less useful, costly, or risky, it may shrink across generations. Another hypothesis is injury avoidance. Imagine several large tyrannosaurs feeding close together around a carcass. Long arms sticking forward could be bitten, broken, or trapped. Short arms tucked near the body might reduce exposure. This idea is debated, but it shows how small arms could be more than a failure. They could be part of a safer feeding design. Another possibility is close body function. The arms may have helped with pushing up from a resting posture, holding a mate briefly, gripping something close to the chest, or performing limited movements that did not require long reach. These are hypotheses, not settled facts. The fossils give clues, but they do not record behavior like a video. That is the scientific caution. We can measure bones. We can compare proportions. We can study muscle attachment areas. We can model ranges of motion, we can look at related animals and evolutionary trends, but we cannot honestly say there is one final answer that solves every detail of T-Rex arms. The arms are a fossil clue, not a punchline. They tell us about a predator whose body was not built around grasping hands. It was built around a skull-dominated feeding system. The head took over. The jaws became enormous. The arms remained small, tucked, and limited. Now watch the animal move. Heavy foot presses into mud. Water shakes in the footprint. The torso shifts forward. The tail counters the weight of the skull. The head lowers again, not like a monster snapping blindly, but like a specialized feeding apparatus moving with control. The small arms flex once beneath the chest and return close to the body. They do not need to look impressive. They only need to fit the design. Evolution is not an engineer trying to make every part equally dramatic. It is a filter acting on survival, reproduction, cost, risk, and function. A reduced structure can remain if it is not harmful enough to disappear completely, or if it still performs limited tasks. A huge structure can grow if it gives a strong advantage. T-Rex shows both processes in one body. The skull became extreme, the arms became reduced, the animal became iconic because those two facts clash in our minds. The joke survives because the contrast is visual. We see a giant head and tiny arms, and the mismatch feels absurd. But fossils are full of mismatches that make sense once the whole animal is considered. The arms were small because the entire front of the predator had been reorganized around something else. Bite neck power, skull mass, balance, feeding mechanics, risk reduction, possible limited arm use. All of these ideas belong in the same frame. None of them turns the arms into a single, simple answer together. They correct the image. A T-Rex was not helpless because its arms were small. It was terrifyingly specialized because its arms no longer needed to be the main tools. At dawn, the animal steps away from the carcass. Mud pulls at its feet. Its jaws are heavy. Its neck holds the skull low, then lifts it into the pale light. The tiny two-fingered arms remain close beneath the chest, no longer framed as a mistake, no longer framed as a joke. They are part of the same animal as the skull. A predator built around the front of its face. A body where the killing machine moved forward and everything else changed around it.